Algebra 2 Honors 4.6b, still on the fundamental theorem of algebra, and we're going to look at Descartes' rule of signs today, which tells us more about how many solutions, positive or negative, to expect in a polynomial. So we're going to go ahead and jump right into Descartes' rule of sign. And if you have this polynomial, the number of positive real zeros of this function f is equal to the number of changes in sign of the coefficients of f of x, or is less than this by an even number. So let's just go down to example 5. And so what you do on this is the first coefficient is positive, the second coefficient is negative, and so that's one sign change. So there's one sign change. And then from -5 to -3, that's not a sign change because it's still negative. But from -3 to +3, the sign change from negative to positive, so there's another sign change. Then +3 to +10 is not a sign change. They're both positive. +10 to +1 is not a sign change because they're both positive. But from +1x to -9, that is a sign change. So there are 3 sign changes. So the number of positive real zeros is equal to the number of changes, or is less than this by an even number. So you go down. So there will be 3, or go down by 2. There will be 3 or 1 positive real solutions, or zeros. And that's for the number of positives, so those are to the right of the y-axis. Then for the number of negative real zeros, you have to replace x with negative x in the function and count the number of sign changes. So we need to take f of a negative x, so putting a negative x in for all of the x's. And then simplifying those. And so you'll get 2x to the 6th. A negative x to the 5th will be negative, times a -5 is positive. And a negative x to the 4th is positive x to the 4th. So we have a -3x to the 4th, and then we get a -3x cubed, a plus 10x squared, minus x minus 9. So now that we have replaced x with a negative x, this is for finding the number of negative real zeros. There's no sign change from 2 to 5. They're both positive, but from +5 to -3, that is one sign change. From -3 to -3, the sign did not change. They're both negative. But from -3 to 10, it's a change in sign from negative to positive. And then from +10 to -1, that's another sign change. And then from -1 to -9, there's no sign change. So this means that there are 3 or 1 negative real zero. So we have all these different combinations, and the degree of this is 6, so we have to have a total of 6 zeros. So we could have 3 positive real zeros, and then we could have 3 negative real zeros. That would take up all 6 of the zeros, and there would be no imaginary zeros. Or we could have 3 positive real zeros and 1 negative real zero, And to get the total of 6, that would leave us with 2 imaginary zeros for that total of 6 zeros. Or we could have 1 positive real zero with 3 negative real zeros, and that would leave us with 2 imaginary for a total of 6. Or we could have 1 positive real zero, 1 negative real zero, and then we would need to have 4 imaginary to have a total of 6. So this is, you need to make up this chart with all the different combinations of possible real and negative zeros. And so there's going to be at least one place to the right of the y-axis that this polynomial crosses, and at least one place to the left, because you have to have at least one positive real and one negative according to Descartes' rule of signs. So you could pause and see if you can do the next one on your own, or we'll just go ahead and go through it here. So you start by counting the number of sign changes. 3 is positive to -7, that's one sign change. And then -7 to a +1 is another sign change. And positive x to a -13 is another sign change. And -13 to +8 is another sign change. So that means you are going to have 4 or go down by an even number 2 or go down again by 2. You keep on going down until you hit 1 or 0. And so you could have 4, 2, or 0 positive real roots. So you less than this by an even number. You keep on going down by 2 until you get down to 1 or 0. And those are all the different possibilities. Now we have to check for the negative, so we need to replace x with a negative x. And if you simplify those, negative to an even is going to be positive. A negative to an odd is going to be negative times a -7 is positive 7x cubed. And we get a plus x squared, and negative times a negative is plus 13x plus 8. And there are 0 sign changes because they're all positive. So that means you will have 0 negative real roots, or zeros, either way you want to say it. And so by Descartes' rule of signs, I actually know to not expect this polynomial to ever hit the x-axis to the left of the y-axis. That's kind of neat to know by just looking at those signs. So we're going to start with if we had all 4 positive real zeros, and so this is of degree 4, that would take up all the zeros, so there would be 0 negative and 0 imaginary for a total of 4. Or we could have 2 positive real zeros. We know that there are 0 negative real zeros, leaving us with 2 imaginary for our total of 4. Or we could have 0 positive real zeros, and we have to have 0 negative real zeros, and that would leave all 4 zeros to be imaginary. And then we just don't need that last column. So you might need extra columns, or you might not need all of them. And so that's Descartes' rule of sign. Then just a little application problem here. And for this one, I want you to use Desmos to get the graph of it once we get going. So let's see. A tachometer measures the speed in revolutions per minute, RPMs, at which an engine shaft rotates. For a certain boat, the speed in hundreds of revolutions per minute of the engine shaft and the speed s in miles per hour of the boat are modeled by this function. What is the tachometer reading when the boat travels 25 miles per hour? So the speed s is your 25 miles per hour. So, and we want to find the tachometer reading, which is the speed x, that's the variable x. So what should x be so that the output is 25? So what we're trying to solve is this. And so what you're going to do is we are looking at zeros. And so I'm going to set this equal to 0 by subtracting 25. And that's going to make this a minus 36. And right here, this would be your f of x. There's one sign change, there's another sign change, and there's a third sign change. So there are 3 or 1 positive real zeros to expect. Now, x won't be negative, so I'm not going to bother checking f of negative x because the negative zeros I'm not interested in because that doesn't make sense for this application. And so now what we're going to do, we know it has to at least cross once on the positive x-axis. It could actually cross up to 3 times, but we're going to go ahead and put this into Desmos and graph it. So graphing calculator, and then I'm going to delete what's in here, I think. Or maybe I can just, there we go. And so we have 0.00547 and then x cubed minus 0.225 x squared plus 3.62 x. And then remember we subtracted over the 25 because then it's easier, to solve this by looking at zeros. Well, right now I'm not really seeing anything in the graph, so I need to zoom out and see if we can't find this. Oh, there's something. There's something. So on this, I want you to put the window that you use. So I'm really looking for this 0. And that's at 25.246. And so go back and sketch this graph. Do a little sketch of it. And we can go ahead, we could zoom in a little bit more if we wanted to. But whatever window that you're using, so right here I've got, I'm going to zoom in just a little bit more. So negative 10 to 30 for my x, and negative, say, 25 to 15. So I'm going to go back, oops, sorry, and sketch that. And I'm going to give that the x scale I've already forgotten what it was, negative 20 to something, negative 10 to 30. So this is negative 10, 10, 20, there's 30, and my y scale was done at negative 25 to positive 15. And that answer was like 25.246. So it's about right here in terms of that 0. Approximately. And I go back and try to look at what that graph looked like again. Kind of came up like this and then sketched through and kept on going. So, and then this is around negative 25, and this is up around 15. So we'll just do it just like that. And so now that X value, though, is in hundreds of RPMs. So what is the tachometer reading? It's in hundreds, 25.246 hundreds, right, of RPMs. So if I multiply by 100, it's 2,525 to the nearest RPM, rotations per minute. That's it.